Alright, this video is just a quick explanation of how to use the distance and midpoint formulas. Again, they're just two fairly basic formulas that are going to help you find the distance between 2 points, such as the 2 points on our screen right now, 3, 4, and -2, 1, and then also how to find a midpoint, a point that's halfway in between both of those points. Again, the distance formula is essentially kind of an extension of the Pythagorean theorem. You can notice in the formula up here where it says x minus x squared plus y minus y squared. Basically, if we find a distance left and right, that's the x minus x, and a distance up and down, we're finding two legs of a triangle. So if we were looking at the points 3, 4, and -2, 1 on our graph, if I went over 3 and up 4, and we drew ourselves a point on our screen here, if it'll let me here, there we go, and we drew a point in there, and then also we went -2, 1, and we drew a point right here. What we would want to do essentially is connect those 2 points and find the length of the line in between those 2 coordinates. So if we were finding the length of the line in between those 2 coordinates, again, we're just basically finding a leg going to the right and a leg going down on a right triangle. And x minus x, or on our screen, if we said the distance formula equals the square root of, again, if I take x2 minus x1, let's call this one x, we'll call this point number 2, and we'll call this point number 1. So -2 minus 3 squared is basically saying from -2 over to +3, that distance left and right is going to be 5 units across. Or if we kind of continue that distance formula down here, the first thing I would do is say -2 minus 3 is -5 units squared. Then we're going to add on, note in our formula, just like saying a squared plus b squared, right? Our y minus y. It doesn't really matter which one's which, but since we used -2 for point number 2 before, we'll call it 1 minus 4 squared, which again 1 minus 4 is -3, which essentially you figured out to get from 1 to here, that's really 3 units up and down. Again, the negative won't really matter because the minute we square this, that becomes +25 plus +9, and d equals the square root of, note it wasn't d squared, just like the Pythagorean theorem, we have to take that square root at the end. But d equals the square root of 34, or if we pop that into our calculators, the square root of 34 should be just a little bit less than 6, because remember the square root of 36 would have been 6. So the square root of 34 comes out to 5.831. 5.831 units. And that essentially becomes the hypotenuse of, right, our triangle. Now, the midpoint formula, what it does for us is if we take 2 points, such as -2, 3, again, putting a point right here, and 4, 5, it's going to find us a point that's perfectly halfway in between those points. And if you look carefully, you may be able to sort of notice that that halfway point seems like it should be at about 1, 4, visually. But we want to verify that algebraically. We want to be super sure that that's really the case. And really, all the midpoint formula is going to do is average the 2 points together. Notice in the formula up top, what it's basically going to do is take the 2 x's and add them up. So -2 plus 4. But then I'm going to divide by 2. I'm taking 2 items, adding them up, and dividing by 2. I'm basically averaging the 2. And -2 plus 4 is 2, divided by 2 is 1. And just like we said, that midpoint should be at about x equals 1. From left to right, halfway in between will be right there. So then let's do the same thing with the y values. We're going to take our 3 plus our 5, giving us 8, but divide that by 2, and 8 divided by 2 is 4, and as we thought, it's up at 4. Over 1, up 4, there is our midpoint of our other 2 points. So the midpoint and distance formulas are fairly easy to use. One thing we can do with them is help ourselves sort of prove things geometrically. So if we have a triangle with 3 different points on it, a fairly involved problem is actually to prove whether or not this triangle is an equilateral triangle. An equilateral triangle is a triangle with 3 equal sides. So what we would want to do is take point A and point C, and we throw those into the distance formula, and we could figure out that they would be approximately the square root of 85 apart. So again, we could find that decimal if need be. However, to prove they're equilateral, we just need to know, are the other sides also all the square root of 85? Well, if we take points B and C, we find out that they're actually equal to perfectly 12. So already I know this isn't an equilateral triangle. Already I could say, well, BC does not equal side AC. It just so happens that side AB is the square root of 85. Again, if we use points 1, 3, and -5, -4. So 2 of our sides would have worked. This is actually an isosceles triangle, a triangle with 2 equal sides, just not an equilateral triangle, a side with all 3 equal sides, or a triangle with all the 3 equal sides. So no, it's not going to be an equilateral triangle. BC is not equal to the others. Now, we could find the midpoints of the sides, though, and let's find out if this is an isosceles triangle, we just figured out that AB and AC are equal length. Well, could we then also figure out that if we connect D, E, and F, right, find those midpoints of the sides, well, take all of the points, we're going to add up all the x's, divide by 2. So if I want to find point D, I'm going to add 1 to -5 and divide by 2. And if I want the y-coordinate, 3 to -4 and divide by 2. And notice I get a new coordinate. It's sort of 2 formulas in one. I found both x and y. Do the same thing to find point E between A and C. So again, 1 and 7, 3 and -4. Add them up, divide by each of them by 2. And then the same thing for point F along the base, along that bottom side. Now, if we form that triangle again, right, if we actually take those, and again, connect those sides. So if I went D to E, E to F, and F to D here, right? If we take that and connect those side lengths, does that form an isosceles triangle? And in that case, we need to take our new 3 points, D, E, and F. Let's find DE, DEF, and DF. We'll find all 3 sides, and it so happens that, yep, EF and DF on here, and right here, are 2 equal side lengths. Thus, because they're the same, yes, that new triangle, DEF, would be an isosceles triangle. I hope that helps you understand easy ways to use the midpoint formula, again, to find a point halfway between 2 other points, as well as the distance formula to find a fast way to get the distance between any 2 points on a graph. If you have any questions, make sure you talk to your teacher. Otherwise, good luck, have fun, and happy counting.